Right, good evening, students. I'm sorry, I've been trying to connect to the class, but it didn't let me for the last few minutes now. But luckily, I think I could finally connect. So for some reason, I think when I try to connect, it requires a bit of push, I think, in terms of internet speeds as well. So sometimes I do experience in connection. I hope it is clear now. Are you able to hear me clearly, everyone?
Yes, sir.
Great. Right. So where did we stop in the last class? In last class, we finished talking about majority of the aspects of epidemiological transition, correct? Epidemiological anthropology. We also briefly talked about epidemiological transition theory, and I provided information on NCDs, non-communicable diseases, and Indian scenario on non-communicable diseases. Okay. Right. So, but I also want to give a bit of perspective on COVID as well, because as part of non-communicable diseases that we learned that over a period of time, as per the epidemiological transition theory, as we grow, as any country grows, we notice that we are able to better handle the communicable diseases, but eventually the chronic diseases like non-communicable diseases increase. But the thing is, this may not be entirely true. It may not be that we just follow the exact same trend that is described by Omran and other people who added this information to it. So at times what might happen, we may see some communicable diseases showing up, right? And the story of emerging pandemics is happening now. The story of emerging pandemics had begun. Correct? So the transition theory may or may not completely hold the reality of it. Correct? So we definitely are seeing kind of the pandemics, either emergence of new pandemics or re-emergence of the old pandemics is taking place. Correct? The scenario is slightly different. In connection with that, I'm going to show you a few articles. Okay. One that actually was published in Down to Earth and one from World Economic Forum and one research article. The idea here is that scenario is probably not just that, okay, we are done with the communicable diseases and non-communicable diseases we're struggling with. Our focus should be mostly on them. It's not that. I think even we have some infections are coming back and causing us more issues, and more pandemics are being felt. And this century has witnessed, I think, several folds. When I say this century, about 100 years, since last 100 years, maybe since 1918 to the current pandemic, I think there are more and more pandemics are showing up. So definitely there's a changing trend to this. So with respect to that, I would like to show you something. Just develop an idea as I'm speaking to you. Write some key points, because in case if you get a new dimension in the exam related to this, you should be able to answer it. Okay, and make a note of a couple of articles. I'm actually going to share the links of these articles with you. First, I think the simple connection that can be taken from this Down to Earth article. So this article, which was published in July 2020, it says COVID-19 other crises prove existence of not one but several epidemiological transitions. Because in the last session, we talked about epidemiological transition, but there exists probably multiple other interventions to this transition that is explained by Omran. Okay, so as part of this article, they briefly talk about that the theory of epidemiological transition given by Abdul Omran. They talk about this concept in three stages. We kind of talked about the age of pestilence and famine. So age where diseases show up, and when diseases show up, famine also shows up, or just immediately after the disease condition, famine shows up. And the age of receding pandemics, then eventually we get used to it and the pandemics go down. And the age of degenerative man-made diseases, we talked about it, non-communicable diseases. But then Olshansky in 1983 has added fourth stage to this. So there may be a fourth stage. The fourth stage is where the age of delayed degenerative diseases. So degenerative diseases, I think we also talked about that. We also get a hold on degenerative diseases. If you go to developed countries, I think we talked about it, screening for cancers, those things happen. So because of these interventions, even delay happens with respect to degenerative diseases. Another stage is added later by Martens in 2002, where the age of re-emerging of infectious diseases. age of re-emerging of infectious disease, the fifth stage. So we are already witnessing this fifth stage, re-emerging of the infectious diseases. So we are experiencing probably the last three stages of epidemiological transition simultaneously. This concept is very, very important. So we might be seeing the age of degenerative and man-made diseases. We are seeing the delayed degenerative diseases. We are also seeing re-emerging of infectious diseases. I think all three probably happening simultaneously, maybe different parts of the world at different rates, but these are there. Okay, right. Wherever you are not able to follow, do stop me there. We'll discuss about that. So, and in the context of that, we are seeing that the pandemic of COVID-19 is greatly troubling us at this moment. Okay, so, and if you see in connection with that, I'll show you this particular article that actually had come in the World Economic Forum. They've nicely discussed a brief picture about how these pandemics have changed over a period of time. So you notice here that they have briefly talked about how these pandemics have happened over a period of time. Okay, olden days, I think I also briefly gave you a few of these connections, correct? We talked about early stages where we had some sort of infections that happened, killing probably range of people. I think probably the highest was 200 million people died from Black Death disease or plague. I think I was briefly talking to you, correct? Florence, we talked about an example in the Florence at that time, right? 1347 to 1351. 30% of the European population, more or less, was killed as per the records. Part of this, like this plague, for example, smallpox, Japanese smallpox, and another smallpox, and another plague, rounds of plague again, cholera, we're talking about 1800s here, and a plague that went around for a few times in these centuries, 1300, 1600, 1700, yellow fever, right? And again, another time plague. And the more recently, if you see the last century, I think we've seen the higher amount of or more increased rate of infections, like HIV AIDS, 1980s to today, probably have killed over 25 to 35 million people. 1957 to 1958, Asian flu, Hong Kong flu, 68 to 70. And then MERS, SARS, Ebola, swine flu, now COVID. Look at the number of infections that have increased in the last century, right? Even before that, the actually rate of emerging of infections or re-emerging of infections was small. But in the last century, we have seen so many of them, starting with HIV, AIDS, and Asian flu, Hong Kong flu, and influenza viruses, and MERS, SARS, Ebola, swine flu, novel coronavirus, and bird flu also we are hearing. And in addition to that, we heard the Zika and dengue, chikungunya was also becoming an epidemic and moving to different countries in the process of becoming pandemic. So definitely, I think we are in the era of emergence of new infections and the re-emergence of the existing infections. Correct? So definitely we are seeing that fifth stage that was added to the transition theory, epidemiological transition theory. Develop an idea about this and have a little bit of data on this. So in the exam, if they decide to give you, ask you something on this end of how we are noticing a different stage of epidemiological transition theory, because I'm seeing that in the anthropology exams, they're actually twisting the questions a bit, and this type of component is very, very important for the exam. Okay, I'll share the links to these articles. You don't have to read it entirely, just wanted to take the great images in them. I think as per this image, I think it was slightly old, last year's data, right? So at that time, they only had about 4.7 thousand people died. But indeed, right now, I think 2.5, close to 2.5 million people died from COVID. So COVID after HIV and a few like rounds of plague, I think COVID-19 has become now or added more death toll. So about close to 2.3, 2.5 million people died from COVID-19 so far, and it affected, I think as per the last night records, 106 or 107 million people infected. So definitely it is becoming one of the biggest problem or infection of all time. But of course not close to the 200 million deaths happened from the plague. Because at that time, of course, we had not much of knowledge, awareness, technological intervention was less. Today, we have better diagnostics. We quickly brought in the vaccine, correct? And also, of course, we don't have a treatment option for COVID-19 yet, but we have better understanding about how immune system functions. We are able to use steroids to stop the immune system, especially the cytokine storm that we hear, or where immune system is starting to attack various parts of the body during COVID-19. So now we have better understanding about it. We are actually using some form of drugs like steroids to kind of prevent or suppress the immune system from attacking our own tissues. Correct. So we have a bit more technological advancement. Of course, we don't have any proved drug yet. I think most of the drugs you heard, they're repurposing what we are doing. So the drugs meant for HIV, the drugs meant for Ebola, drugs meant for treating some parasitic infections like ivermectin, and we were actually using hydroxychloroquine meant for treating malaria, right? Those type of drugs, what we were using. And if you read the WHO's final kind of analysis on this at the moment, none of these drugs proved to be working. Okay, plasma therapy. We are working on plasma therapy, the new technological intervention where we are not new. Indeed, actually, this was used a century ago. Like collecting antibodies from the recovered patient and injecting into the person who is suffering from it. So the ready-made antibodies, which is part of passive immunity, like passive smoking, I was telling you briefly. So someone made the antibodies against COVID-19 during their infection. So collecting that plasma and giving that plasma to the patient who is suffering from it now seems to help to a certain extent. But again, ICMR, All India Institute of Medical Sciences, has not showed anything greatly positive on this side. So plasma therapy is very unpredictable. And this is not the case with just COVID-19. Even before that, SARS, MERS, the attempts towards that didn't work very well. So we don't have actually a good treatment option. I think it's all about your immune system and your other comorbidities like diabetes, heart-related problems, and the age factors. I think this is what kind of define whether we are going to survive with COVID-19 infection or not. I think on average, 5% of people seems to be succumb to this type of problems because of COVID-19. Okay, so definitely, I think we are on the verge of getting more and more pandemics. I think the reasons might be known if you see in the literature, any of these diseases. I think they clearly talked about the time period in this article, Japanese smallpox and flus, various flus and plague and HIV, AIDS. So briefly, they talked about how they were coming. And if you notice that most of them were zoonotic infections, they're coming from animals to us. Why? What is the reason? Why are we seeing more and more infections coming from animals to us? I think in the last class we briefly talked about this. One, because we actually started raising them, domestication process. We are now are more and more exposed to animals. So viruses, which can easily mutate and adapt to the new host, are becoming common now. They're able to enter into our body and cause infection. They are adjusting to us slowly. I think as soon as it enters into our body, it is called spillover. You sometimes hear the word spillover in the news. Spillover. So going from one host to the other host. They may not rightly adapt to the new host. It will take time. They have to undergo mutations. But what is the benefit for them? They actually multiply every few minutes. And imagine its generation time is minutes. So within our time frame or within few days or few weeks, they can get enough chance of mutations. That is why in the COVID-19 time in last 1 year, we heard about so many mutant varieties. That is the nature of them. They're able to actually evolve part of natural selection and able to sustain in our bodies. Like that, we are probably are more and more exposed to these type of components. So it could be the concept of agriculture and connectivity, global connectivity, and also deforestation. Now more and more creatures like vectors are coming to us because they don't have enough space left. Their habitation is actually disturbed by us because of human activity. So they're coming to us. That is why we are seeing new vectors carrying the disease. We are seeing new viruses which are able to infect us. Maybe old virus, but it is re-emerging, causing more issues. That is what kind of they talked about in this article. This is published in Cell, where they focused on emerging pandemic diseases, how we got to COVID-19. You don't have to read everything because it's a 16-page article, but you basically see that infections are becoming more common, as I was telling, for various reasons. It is because of several factors. The disease emergence is indicating that the dynamic balances and imbalances within the globally distributed ecosystems, where humans are there, animals are there, pathogens are there, and the environment. I think we all are trying to, living in close connection to each other. So we have now better bridging between animals and us. So where viruses can easily enter and cause more problems to us. And most of the recent infections are viral infections. They are able to adapt better, faster than bacterial diseases. We have something like TB, tuberculosis causing the problem, but still that is dealable. We can actually, that is a manageable problem. But viruses, we don't have good treatment options, don't have good vaccines. We're still struggling to control them. And unfortunately, they are actually on the rise. There's no doubt about that. So these are, of course, this paper talks about the various components, and interestingly, terminology that we probably need to know. I think I already covered them: endemic, epidemic, and pandemics. We don't need to know all these components, but zoonotic diseases is something that you may need to know. Infections coming from animals to us, are transmitted from animals to us, are called zoonotic diseases. They briefly talked about here. I think one interesting one I wanted to show you from this article is the categories of infections, the major categories of emerging infections. The major categories of emerging infections. So newly emerging diseases. HIV/AIDS is new. We have not seen it before 1980. Nipah virus was new 1999. SARS, MERS, COVID. These are all newly emerging infectious diseases. They are related. COVID-19, SARS, MERS are related to each other. But this COVID-19 virus, SARS-CoV-2, evolved to become something different. And also be aware that, I think I was mentioning, re-emerging infectious diseases. Already old diseases, but they are beginning to re-emerge. Re-emerging. So example of re-emerging diseases, West Nile in the United States and Russia. Already there, it was re-emerging. And you do hear of Ebola also. Ebola is a new one, but was re-emerging. New in the sense it was actually reported much earlier than that. And new infections show up in Congo and other parts of Africa. Similarly, resistant forms of diseases, like the well-known superbug called MRSA, or methicillin resistant Staphylococcus aureus, or Delhi superbug it is called. Right? So some of these are actually resistant to many antibiotics. So old disease coming with more and more resistance towards well-known antibiotics or drugs. So there are also quite a bit of them re-emerging. So newly coming diseases, re-emerging diseases, and some of them deliberately emerging diseases. I think today's newspaper, I have seen that the WHO team that went to China, Wuhan, have declared that the disease that was actually thought to be created in the laboratory, that as kind of complained by Americans that Wuhan lab probably might have created SARS-CoV-2. But as per the indications, I think that may not be the case. But even if not COVID-19, maybe there are some deliberately emerging infectious diseases, like bioweapons as part of bioterrorism. We may have anthrax. I think in Russia once, this anthrax that was actually kept in the lab came out and killed a few hundreds of people. So some infectious agents are part of our research. They are there, we probably keep them for studies and research. They may escape from those facilities causing problems. So like that, we may notice that we actually have some deliberately emerging infectious diseases.
There was another article just a day before, I think, about swine flu or bird flu.
Bird flu.
Some variants which are like lab produced variants are there in the wild, and a new variant naturally mutated is coming out in probably China. There was an article around this.
Right. So
Not sure when.
Yeah, so I think we will see that this is happening more commonly these days. Hanta virus had come. So some of these components are coming back because that's the nature of it. And also because of human activities, as I was telling, a lot of global connectivity, deforestation, and we noticed that issues, political rivalry between countries, where I think bioterrorism was also taking place. So I think we are becoming more and more vulnerable, and it's easier to bring in those infectious agents rather than bringing bombs. Correct? If you bring anthrax and leave it on a country, in a small vial is maybe sufficient for, because the viruses will themselves multiply if they find the right host, causing enough damage. So it's a big threat. Definitely, it's a big threat, and intentionally or unintentionally, these are happening. Okay, so these are the three major categories I want to talk. Fourth category also they discuss here briefly, but they're nothing but the something that we use in vaccines. Polio can happen because of the vaccine as well. Very few people, but they can get. So like that, few vaccines can also become part of causing infections, but rarely. Otherwise, three categories I wanted to be aware about: newly emerging diseases with examples. Make a note of these examples. Newly emerging infectious diseases. So this is kind of the current update to the epidemiological anthropology. This is one unit where we have a lot of scope for current affairs part.
Sir, how can the vaccination cause the infection?
Right. Good question. So vaccines are of different types. So some vaccines, especially traditional vaccines, we use live attenuated pathogens, meaning the virus is alive, but it cannot cause infection. In the normal scenarios, it cannot cause infection. That is the case with oral drops, polio vaccines. Okay, but what happens when a person's immune system is weak? Even this weak pathogen cause infection. Okay, or sometimes they can revert. Changes can happen even within that vaccine, within that virus that is used in vaccine, and can cause infection. As I was telling you, it may happen in 1 lakh or 1 in 10 lakhs of people or 1 in 1 million people, but even those rare conditions are noticed. Okay, so in that sense, it is actually how vaccines can cause the infection. So they are able to provide. This debate always happens. I think I was reading somewhere that they said, I think the protest against vaccination is also increasing. Some people tend to believe that vaccination is not good, is not needed. But indeed, I think if we see in India as well, as part of many like vaccination programs, we are able to save children from a lot of deadly diseases. So definitely there is more benefit of immunization process. But of course, at the same time, we have few issues with it. Few people, their bodies may not tolerate it. Okay, sometimes they may get infection from the vaccine itself if their immune system is weak. Okay, right. Have you made a note of these examples? Newly emerging infectious diseases, re-emerging infectious diseases, deliberately emerging infectious diseases. Okay, so just know that there is some peculiar thing happening with respect to the transition, epidemiological transition component. Okay, right. Yeah, I think this is what I wanted to talk to you. I don't think we need much more than this. They actually nicely mapped various diseases that are happening, newly emerging, re-emerging, deliberately emerging in various parts of the world. But that's a bit too complex for us. But if you want, I can send you the link for this article. So just have a brief look at it. Okay, right. So yeah, that is what I wanted to briefly talk to you in relationship with this part. Have you happened to see the questions from this unit? And what did you feel? Would you be able to answer those questions? I think some of them we already discussed, right? Evolution of disease and major causes of ill health in human populations. So you have to describe diseases, okay, that are common in human populations. So here you have to discuss both communicable and non-communicable diseases. Evolution of disease and major causes of ill health in human population. Also partly discuss about the evolutionary process, what factors led to the emergence of these type of diseases. Okay, next I think I mentioned to you briefly epidemiological anthropology short notes, scope of epidemiological anthropology, study of infectious, non-infectious diseases, and write short note on this. Yes, I will discuss it. Discuss the role of anthropology in understanding of health and disease. The first component, I've already telling you this. What specific understanding is available with respect to infectious, non-infectious diseases? So same question repeatedly asked. So what is meant by epidemiological transition? Elaborate upon its causes and consequences, highlighting major health problems of our adult population today. Okay, so you're mostly you focus on some communicable but mostly non-communicable diseases like diabetes, cardiovascular problems, lung issues. So our adult population is facing the higher burden of NCDs. This is what we would talk about. In today's scenario, we will also discuss about the COVID-19 scenario. Next, briefly discuss the important causes of the variations and intensity of parasitic diseases among different populations. Okay, so here you talk about something like malaria, right? That is a well-known example for this. Otherwise, schistosomiasis, right? And elephantiasis, elephantiasis. Okay, also caused by some of those organisms. So they asked this an old question about 8 years ago. This question had come. Variations and intensity of parasitic. So sometimes they may ask, I think current time, they may ask something like the new viral diseases or specifically about COVID-19. So those type of questions are possible in the current scenario. Okay, and right, short notes have come sometimes on communicable diseases and social concept of disease. Okay, in the social context, how disease is taken. Either it could be the evolution of the disease components that we talked about, or sometimes how disease is considered in the social context. I think they don't focus too much on the biological nature of it. They mostly focus on it's like a curse to the given population, or you notice that certain diseases happen because someone might have done something wrong. So those components you may normally see in the social context. They don't rely too much on the biological reasoning of the disease. Rather, they focus on they look for other alternative reasons for the diseases to happen. The same way they also treat the problems. Correct? Even the way they handle the disease is also very, very different. In the olden days, how smallpox was dealt with, right, is very different from how in modern days we are dealing with the diseases. Okay, right. So otherwise, mostly I think epidemiological anthropology discussion scope, infectious, non-infectious diseases. The two most commonly asked questions repeatedly, but some scope for asking questions on the new dimensions on the emerging diseases. Okay, right. So keep in mind when you're working on it, if you want some information or idea on this, do let me know. Even you can message me on that so I can actually help you with some information on that. Okay, right. This is where I wanted to actually end the epidemiological anthropology part, and we'll start discussing about the next unit, that is unit 10. Okay, unit 10. Look at what is given in the unit 10. Unit 10 is actually a very, very important chapter, the unit for the exam, because in the exam, so many questions have come from unit 10 part. Okay, like 9.4, 9.1, unit 10 is also a topic where questions normally come. So goal of this unit is understanding different aspects of human growth and development. Understanding different aspects of human growth and development. So first we have to start understanding what is human growth and development. Are they both mean the same? Or are they different? So this question had come in the exam. So I'm going to focus on providing a comparative analysis on growth and development. And then we'll talk about various stages of human growth. What are the different stages of human growth? They asked prenatal, natal, infancy, childhood, adolescence, maturity, senescence. So we are going to discuss a bit in detail about these stages, okay, in connection with each other, some major events that take place during these stages. Next, we are going to talk about factors affecting growth and development. So what factors influence our growth? Like genetic factors, environmental factors, biochemical factors, nutritional, cultural, socioeconomic factors. We are going to focus on variety of these factors. Then we're going to talk about the concept of aging and senescence. Why do we age? How do we age? What theories? What are the theories that talk about aging? And we are going to talk about social theories of aging and biological theories of aging. How aging is considered in social context and also in the biological context. And then we'll talk about biological and chronological longevity. The difference between biological age and chronological age. Short note is possible on something like this. We're going to discuss that. Plus, I think one specific topic that also usually comes in the exam is somatotyping. Somatotyping, human physics and somatotyping. Okay, and finally, I think I'm going to cover the last topic in between, methodologies for growth studies. Okay, mostly with factors or before or after factors I'm going to discuss. How do we conduct studies? How do we perform experiments in understanding and things related to human growth? So this is a bit of experimental part. So I'm going to tell you the different methods of collecting data, understanding human growth aspects, and also we're going to discuss here as part of this, the comparison. Okay, brief comparison and issues with respect to some methods. Right, so this is the 10th unit, slightly longer unit. There are many topics that we have to cover under this. So I think Wednesday, right? This Thursday, Friday, Saturday. So most of this week we are going to discuss unit 10. Okay, right. So let's begin with the first part. So what is the concept of growth and development and how are they compared to each other? So what does it mean by growth? In literary sense, what does it mean by growth? And do you consider the words growth and development being similar? Because I do hear sometimes we synonymously use these words. So what does it mean by growth? Any one of you?
So changes in the body,
So changes, growth, okay, changes in the body, okay, right? So changes
like
that we can see.
increase in height, increase in the muscles.
Okay. So basically growth, increase in various aspects of the human body. Okay.
And development may be psychological, kind of.
So development, okay, more psychological. Okay, I see the point. So right, so growth, as you rightly pointed out, is the change that we see physically in probably throughout the body or parts of the body, right? So that can be normally considered as growth. So we'll take up few definitions on that. So in the exam, if you want to write, you can mention them or use few standard definitions for this. But as you rightly said, so increase in the size of various parts or organs of the body is considered to be growth in general. So quantitative change, if I have to use a simple word for this, a more descriptive and concise word is quantitative changes. So mostly quantitative changes in our body are considered to be growth. So change in size. Okay. So as per Watson and Lowry, growth means increase in the physical size of the whole or parts of the body. It means increase in the physical size or quantity, length, height, width, weight. So these type of components come under this. Correct? Increase in the physical size of the whole body or parts of the body is called growth. So we can measure it, right? So height can be measured in centimeters and feet. Normally we use weight can be measured in kilograms or sometimes even metabolic balance. How much are you growing? So basically input and output of the body. How much weight are you putting on, for example, because of the balance between various, parts, reactions that are taking place in the body. Okay. So growth means that. Growth means that quantitative change. How does it happen? What supports the concept of growth? Why? How do we grow? What makes us to grow? So we probably have fewer cells when we are born, right? And we keep adding more and more cells. So addition of cells. So increase in cell number. The concept behind growth or the process behind growth is adding new cells, cell divisions, like we talked about in unit 1.7, and also partly in stem cells in DNA technology and medicine. So increase in cell number leads to growth. We add more cells, leading to the increase in size of various parts of the body. And I think I was talking to you with respect to the fat, body fat, that sometimes we also notice it's not just the number of cells, but also size of the cell changes. Expansion in the cell also can be noticed. Expansion in the cell can also be noticed.
So it means all the cells in the body get multiplied and all of them increase in their cell size.
Not necessarily, but some like fat cells, for example, during some stages, they can expand. But the key aspect of our growth is adding new cells. So I don't say all cells, but majority of the cells in our body do multiply, but some cells cannot. You might have read about nervous system, nerve cells, and heart cells. They don't multiply after some time. We have what we get. Okay, but most of the RBCs, every 120 days they multiply. Egg cells every month they multiply. Like this give rise to a new cell. Sperms multiply on a frequent basis. Skin cells multiply almost all the time. Nails. So some cells are actively dividing, growing. Some cells are there's a variation in the rate of cell division in them. But usually it is cell number that gets to the concept of growth. But sometimes we also notice the increase in the shape of the cell. Like fat cells tend to grow. Okay, expand. Plus, in addition to the change in number, size, sometimes the space between the cells also change. So the overall effect on the change in the size may be because of combinations of increase in number, increase in size of the cell, and also the gaps between spaces between the cells, which is called intercellular space or intercellular substances, space between two cells. So even if that expands, what happens? You will see change in size. So these three together results in the concept of growth, or results in the quantitative change in our body. Okay, right. So this is not something that too complex for you to understand, correct? But now the important aspect that you have to focus on is what is development and how is it different from growth? Is growth and development are the same? So do you see in any difference to the word or term development when compared to growth? Vishal, Nikhil, are you there?
Yes, sir.
Do you want to answer this question? Is development same as growth?
Sir, I keep thinking about the word development all the time, sir. I don't know exactly, sir. Because, sir, like Sunil was saying, it's psychological or something, but uh, what makes sense to me is that growth can be like quantitative physical terms, and development is something which kind of assumption of overall prosperity or overall well-being of kind
Okay. I see it. Okay, right. Anybody else want to add the difference? Any quick difference that you can find between growth and development?
I think it is a more holistic uh, change that includes, say, physical and other items, maybe psychological and.
Okay, right. So yes. So is there a difference?
Yes, sir. I think there is a difference.
In the holistic terms, you mean?
Mm.
Can you put a simple difference? Like, can we say growth is more like a quantitative change? Is development is a qualitative change?
Yes, sir, it makes sense. So, like
Correct?
for example, if there is a family and where like you are providing some input and there is no change in physical like kind of malnutrition is not reducing, but overall the income of family has somehow increased. So you can say the growth is not there, but some kind of development in the family has.
So quantity, in terms of quantity, there may not be change, but in terms of quality, there is change, right?
Yes.
Okay, right. So yes, development can be, I think, can be seen as a qualitative change, but not necessarily just qualitative. Okay, there's no clear discrimination given by people. Synonymously, we use the terms growth and development, but both mean different things. So if I have to tell you a simple difference here, if growth is considered to be the quantitative change, development is more of a qualitative change, but there can be quantitative change as well in the development. Why am I saying it? Sometimes growth is part of development. The concept of growth can be considered as part of development, meaning there is also quantitative change as part of development. But otherwise, if you have to easily differentiate, think growth as quantitative change and think development as qualitative change. So we all grow in size. Sometimes you hear that. Sometimes you hear our parents scolding us saying that you have grown in size, but your brain has not grown. What do they mean by that? It's not about the size they're talking about. The functionality aspect of it is they're talking about, correct? So here we're talking about the concept of attaining that functionality and getting matured with respect to that performance is what is development. So it is an increase in functional capacity. So brain has formed, but brain to function normally requires bit of maturation, bit of exposure. Correct? When you send people to school, they might have some skills, but unless you actually put them through certain tests, certain skills, certain tasks, you may not polish their concepts. You may not polish their skills. So there, what do they do? What happens in the school? They are developing. They are normally we refer to the developmental stages of life. So these are the stages where you are learning and maturing and trying to perform better, attain that functionality aspect, right? Don't you see that? A simple difference I tell you. Children probably have their hands. As soon as a baby is born, baby has hands, baby has fingers. But what about the functionality aspect of it? Can baby actually hold on to something really good? Okay, can baby actually hold and maybe use any type of instruments well? No, they cannot, because they're still in the developmental stages. Baby probably has the tools for it. They develop hands, but how they use the hands requires a developmental concept related to that. It's gripping, holding, like bicycling. So cycling, for example. So it requires a skill of balancing, but the concept is there in the mind. The ability is there, but you're not able to perform it. For that, you need training. So that is part of development process. Holding a pen. As soon as you give a pen to the baby, baby cannot hold the pen the right manner and write it. So they have to undergo that maturation process. And that is what we're talking about in development. It is increase in the functional capacity. I don't know if I agree with the word perfect form or in the form that it works. Increase in functional capacity in the form that it results from the production of specialized tissues from unspecialized ones. Okay, this is focusing mostly on the growth version of the development, where tissues are formed, and tissues formation is one aspect, tissues becoming functional is another aspect. Like stem cells are there, but we want stem cells to give rise to, let's say, heart cells, liver cells, kidney cells. So specialized cells, formation of specialized cells does happen. Otherwise, it doesn't support the concept of development. Okay, and I've given two definitions here. One is from Comas. So where quality peculiar to living matter that carries it through the process of progressive evolution to a state of perfect function. So in the process of attaining or achieving perfection. So it's a quality peculiar to all the living systems or living matter. Okay, within living matter, what happens? The process where progressive evolution, gradual change. So from a time where you cannot hold the pen to a time where you can beautifully write, explain things, write poems. So this is all part of development. It's progressive evolution, gradual change to a state of perfect function. Do you see the difference between growth and development here? It's not just about the change in size, but it's change in performance and functionality aspect. Excuse me. Similar definition was given by Harlock. So changes in progressive series, so same as progressive evolution as given by Comas, but he talked about the aspect of orderly and coherent. So events that are orderly and coherent. So there's an order to that, how that happens, when does that happen, and a coherence of that. So they have to happen in collaboration together with the other aspects of things that happen in our body, leading to maturity. So maturity aspect of the growth is what is development. Yeah, once a question came on this, I think write a short note on they gave differentiate between child growth and development. A question came in 2013 on this, differentiate between child growth and development. Okay, so 10 marker question, growth versus development. And once a question came, I think that we're going to discuss in tomorrow's class. The different factors affecting growth and development in human beings. 2016 question. Different factors affecting growth and development in human beings. Okay, so you should be able to differentiate these two terms, growth and development. So for that, I've collected, I think I was going through, I happened to see, I think a report, almost 200-page report, looks like psychology, comes from the psychology department in India. It's related to some university here. So they nicely laid out the difference between human growth and development. Okay, I've picked a few points. So look at those points and add those points to explain further, because just giving definition may not be enough for 10 marker question, right? So what would you write as a difference between growth and development? So look at the changes here. Growth refers to physiological changes. Growth refers to changes in our physiological systems, various parts, components of our body. It refers to the physiological changes. Okay. So whereas development, as we just talked about, refers to the overall change, especially the change which is orderly and coherent to meet or to attain the maturity. So this is more change in the physiological parts, various components of our body, whereas this is overall change in performance and especially going towards maturity. Second, so change in the quantitative respect. We already talked about it. Growth is more of a quantitative in nature, whereas this is qualitative, may also be quantitative. So it can be both, mostly qualitative, plus part of it can be quantitative, because growth should be integral component of development. Unless brain grows to that stage or carry those components, development will not happen. So they have to happen together. So development is a change in the quality along with the quantitative aspect of that particular organ or overall ability. So growth may not happen throughout our life. We may grow only till certain stage. We'll see that when you actually cross the adolescence, okay, when you get into the adulthood, there won't be growth. There won't be physical growth. Physical growth will stop at one point of time. Okay, it stops after maturation. Growth stops after maturation. After a certain point of time, we stop growing. We don't grow in height. Of course, we put on weight, but we don't grow in height. size of various parts of the body would stop at different stages of our life. So growth would stop at one point of time, maybe different for different parts of the body. And whereas development is aspect which is probably continue throughout our life as we expose, as we actually gain more experiences. That is all part of our development. Correct? So development continue throughout the life, whereas growth would stop at one point of time. Depends on what organ we are talking about, it may differ. But otherwise it has an end point. But whereas development is an ongoing process. So it's a progressive process. Okay, so generally you described here as these examples, the points that you talked about here, basically defining what is growth and does growth is a continuous process or not, and same comparison in the development. Right, first part is that. The second part, the reason, how does it take place? Growth occurs due to multiplication and other things that we talked about, multiplication, increase in size and intercellular space. But most importantly, it is because of the multiplication of the cells, addition of new cells. What about the development? If growth is happening because of addition of new cells, what about the development? Happens because both because of maturation and interaction with environment. So it is defined by multiple things. Environment, like what do you eat, what do you get exposed to, where do you go to school, what books do you read, all sorts of things. Our exposure defines the functional ability of our body. Of course, for this also there will be, I think we talked about briefly on this concept, there must be the underlying genetic component, but on top of that, so genetics plus environment. Okay, so kind of we already talked about the next point, growth is cellular. So at cell level growth does happen, but development is more like a more broader term. That is what you see in both of these points. Growth is cellular and it is one, and growth can be considered as one part of the development. So it could be an integral part of the development itself. But whereas development is a more comprehensive term and more wider concept. Gradual, so it is progressive process, and also more comprehensive term. Whereas growth can be well defined. Oh, this is a growth of this part of the body. But development is more broader in its idea. Okay, so any other differences? The few more differences are there. Okay,
so can we say in the Down syndrome, a person undergoes growth but doesn't undergo development?
Both happens in them, right? They're short, so growth is also not as it's supposed to be. So growth is also affected, development is also affected. Both aspects are there. So growth is also impaired in them. Both growth as well as the development, both are impaired in Down syndrome, for example. Turner's also same thing. So the physical concept, that is the size of them, is also not completely not optimal. At the same time, performance is also not optimal in terms of behavior. So both happen, and they both are related to each other. If growth is not complete, development will also, that maturation will not also be complete. We both are connected to each other. Okay, this first point I think is more or less redundant of what we talked about. The next point, the changes produced by growth are subjects of measurements. So you can quantify the concept of growth. So they're quantifiable, measurable. So you can measure this growth in size. Correct? So they're measurable. So growth is measurable, quantifiable. Development is difficult. You cannot quantify it. Although we have tests like intelligence, IQ tests we talk about. So you can actually assess them through certain tests, like or certain observations. Like normally in brain related things, they would see how well the brain of a rat is developed through certain experiments. I remember seeing in those laboratories wherein like normally they focus on brain development and brain function. So they actually give certain tasks to rats at different ages, and they see how well they perform. Their memory, they check how well they remember. They provide a certain route or a path, and see if a rat can find, maybe something that is eatable to it by following that path. Does it remember the next day? They do experiments on these type of things. So by providing certain tasks, they may find out how well they are developed. So some of them are, I think, to a certain extent quantifiable, but it is unlike the case of growth, where easily quantifiable cases. But here it is difficult, but through certain tasks, you may be able to measure or come to an idea about how much of the development has achieved. Like schools, what do we use? In the schools, we actually put test exams. Based on the marks, we define how developed are they. Did they really learn the skills they're supposed to learn for second class, third class, fourth class, sixth grade, seventh grade? Like, are they now able to capture the information related to the high school? Correct? So there are ways. None of them are perfect. That is why many actually debate whether tests are important. Then do the test really quantify? People who gain very good marks but cannot perform well sometimes. What's the point in it? So definitely those tests are not optimal, but we require some means of testing it, showing that whether someone crossed the required level. So development can be measured, okay, through that, but they're not perfect. Okay, and they also briefly talked about this concept that growth may not bring development. Growth by itself has to happen. Development may or may not depend on the growth. Okay, which also kind of disagree that because unless you have growth, your brain doesn't have those capacity, that cells in them. So maturation may not happen. So for some, we cannot generalize the concept that development is possible without growth. I think growth and development has to go together, hand in hand. Whereas growth can happen without the development, but development requires part of the growth. That is what my belief is with respect to this. Okay, so if you want, in few cases, development may be possible without growth, but usually development, as we already talked about, the growth is an integral part of development. So this is basically the difference exists where how we see it, how we define it, and how we see it. Okay, so few ideas for you to write the differences between growth and development. And as I'm going to pick up few stages of human life, then I'm going to give you examples of. So pick up examples, leave the blank, or already write what I've mentioned to you. So growth means increase in size, cell size, increase in hair size, increase in arm size. Whereas examples for the development is ability to perform certain tasks. Example, gripping things, holding things, cycling, driving skills. Right? We have tools, we have parts, but they only come later, at later point of time. Writing skills, as I was telling. Okay, you can also give a right. So this is brief and development. So next we'll talk about the various stages. And before moving to the stages, different terms, just that you probably know it. So in human development, you may find different aspects of development. I think Nikhil and Vishal were kind of you may have physical development that happens. So development can be seen as parts of different ways of development can be seen. Physical development of the like body, balance, that examples I was telling you, control of movements. So that is physical development. Emotional development. So the feel of excitement, love, joy, pride. So these are emotional parts. As children grow, you start seeing that these emotional components would also develop in them.
Sir?
Yes.
So all these terms, can we say like there can be physical growth or emotional growth or intellectual growth or social growth?
No. Why? Because as we just discussed that growth is something that is more quantifiable. It's not about attaining maturity. So if you say physical growth, yes, physical growth means but here what aspects of development are being able to balance. Apart from the physical growth, correct? So there's a clear difference between here between growth and development here. Growth means having enough size or strength in your hand. But development is where you're able to use it to balance certain things, lift certain things. So this cannot be called as growth. So this has to be development. Right? Similarly, emotional growth. Yes, in literary sense, that is what I was telling you. In literary sense, we interchangeably use the word growth and development. Definitely there's a difference to it. But in real life, we do emotional growth is a common term you hear. Correct? But it is more appropriate to say to development. Because here there's no physical growth that is happening here, no quantifiable growth happening here. Here, what are you noticing? You're noticing certain feelings have generated, like excitement, joy, love. Initially, when children are born, when they're exposed to only their parents, okay, unless they're introduced into the friends, the concept of friendship doesn't begin, right? So those developments would happen because of their exposure. Although we use interchangeably the word emotional growth, referring to the emotional development. But I feel that development is the appropriate term over the growth here. In literary sense, we may not differentiate. Okay. Similarly, intellectual development, being able to think, being able to reason. What happens when you finish the school and college? As part of them, we do certain projects. You get hands-on experience. You may be able to solve problems. The problem-solving skills they develop over a period of time. That requires an amount of maturity. So this intellectual development happens over a period of time. You're able to think, make right judgment, reasoning. Okay, and this happens with time, with age. Also, social development. So being able to interact, being able to adjust with in the social structure of the society, of the school, wherever you go. Initially, you are at home. The one thing I normally see that when children are at home, they believe that everything that they have at home is theirs. I've seen a couple of times in stages with my children. The first child always thinks that all the toys are his toys. Second child comes, he has to start sharing his toys with the second child. You remember fighting with your brothers, sisters? That is all yours. And you always have a feel that it should be mine. I should have equal rights, or I should have actually complete rights. So whenever you want to play, this toy has to be given to you. I see with my 7.5-year-old child and 4-year-old child, they both fight. 4-year-old child says that I need this toy anytime I want to play with. And the elder one doesn't agree. He says you have to share. The concept of social interaction begins there. You have to tell them that you have to share. Same thing with school. There are certain resources that you have to share with others. So this concept of social development happens with our exposure. So culture plays a very, very important role. So personal care, playing with others, being able to share with others, and learning how to interact with others, like his peers, friends, classmates, and also relationships, building the relationship, friendships with people, relationships with people, so that you can get along well with others. So all these things are part of human development. So this is more on the social and psychological component of human development. Okay, right. So you can also focus on these concepts, that variety. You can talk about variety in the growth. We'll discuss some of those biological components next. Okay, so you can also add those growth components and human development components to that, to the list of things that we discussed, we compared. Okay, right. So next theme is discussing various stages. Discussing various stages. So what are the stages of our life, growth wise? What stages do you think from the day probably our life had begun till the death? What stages that you think of?
Infant, child, adolescent, adult.
As soon as the child is born, okay, infancy we talk about, yes, childhood,
Adolescence,
adolescence,
adulthood,
adulthood,
elderly.
right? So on. Correct. So I think they're asking us a few stages that talking about here in the syllabus. Not only after birth, even before birth, they're expecting us to learn. They're saying prenatal stages, before birth, natal, after birth, infant. Okay. So prenatal, natal, and infant, and childhood, adolescence, maturity, and senescence. Elderly we'll talk about, and maturity and senescence, a separate concept we're going to discuss. Aging as part of aging and senescence. Basically, they're referring to the later stages of our life. Correct? So in a very generic sense, this is what we talk about. Prenatal stages come before this. So prenatal, in the mother's womb. Okay, so prenatal, and the baby is born, childhood, adolescence, early and late adulthood, elderly. These numbers may change slightly. The duration may change slightly. I've seen different sources talk about them differently. Okay, but I think I've picked up from one from the, I think, US University. There was one article published by them. They've given a brief table on these stages. So let us be a bit more authentic on this rather than taking something very generic. So I'm going to show you that source. Okay, to write down the list of stages, various stages. But we can just follow what is given in this. But a brief idea I will give, and then I'll get into the details about those stages. Okay, so excuse me. Yes, 520. So this is the article that was published in 2007. This is called An Evolutionary and Biocultural Perspective. Okay. Evolutionary and Biocultural Perspective. Evolution of the Human Life Cycle. So it's a textbook chapter. Okay. So as per this document, so there are different stages as part of our life. A brief idea on that. So just make a list of those stages, and then we'll get into the details about those stages. They also briefly talked about concept of this growth and development and growth, evolution of growth, basic principles that we're going to talk about. So prenatal development, postnatal development. Okay, so prenatal development. So prenatal is the development where various components are there as part of it. So prenatal, before birth. So it includes fertilization. Okay, so prenatal includes fertilization and also implantation and different trimesters. 9-month period of the pregnancy is divided into 3 trimesters: first, second, third trimesters. First trimesters is mostly where we talk about embryogenesis or embryonic development we talk about. Okay, a brief picture, rough picture. I'm going to get into the details about them. So prenatal developments, what is important? Starting from fertilization, we'll discuss about the 3 trimesters: first, second, third trimester. Part of first trimester, we talk about embryonic development. And second, we talk about the few aspects. Second trimester, few changes that happen in mother's womb in the second part of, okay, the second part of the growth, prenatal growth, and third trimester. I'll give you brief points, what changes happens within these trimesters. Because if they ask you, because one question I've seen lately is discuss one stage in detail. So they may ask you to explain one of the stages. So factually, the stage is easier to explain than the other stages. There's enough clearly defined steps that take place here. It's up to you. You can pick up any stage, but they asked once a question like that. So you can pick up something like this, where we talk about embryogenesis, formation of various body parts, and third trimester. Okay. Then this all happens in the prenatal stages. Then what happens in the natal stages after birth? So postnatal development. So first neonatal, newly born, neonatal. We hear neonatal care unit, neonatal intensive unit, NICU we hear in the hospitals, right? So neonatal means newly born, newly born child. So as soon as the child is born, first month, what a month is considered to be the neonatal stage. And then later, or even including neonate, sometimes we talk about infant. So basically this begins as per this begins from the second month. Otherwise, even the beginning is considered to be so. But if you are considering them to be neonate, a newly born child, infancy begins from the second month to, again, this varies. So in general, to the lactation period, end of the lactation period. Lactation may go for 6 months, lactation may go for 2 years. So sometimes infancy is considered to be the 0 to 1 years, sometimes it is considered to be 0 to 2 to 3 years. So it doesn't matter. I don't think we have to be really specific on this. But as for this textbook chapter written by some biologists, so it is from second month to the end of lactation, which is usually by 36 months. So 3-year period is infancy. Then followed by infancy is a childhood. Followed by infancy is a childhood. Childhood goes from about 3 years to 7 years approximately. 3 to 7 years approximately. After infancy, childhood, 3 years to 7 years of time. Then there are few terms that you may hear just to differentiate it. You don't have to talk about all these terms, but be aware about some of these. Juvenile. We hear the term juvenile. So this is time slightly varies between girls and boys because the way things happen in them now differs a bit. So for girls, it is 7 to 10 years, about 7 to 10 years. Approximately, if you remember 7 to 12, irrespective of girls and boys, that is all right, about 7 to 12 years. So between childhood and before attaining the puberty. So this can be considered to be the juvenile period. Juvenile, 7 to 10 or 7 to 12 years. Make a list of these, okay? So it's easier for you to follow the specifics I'm going to deal next. This is the overall idea. After juvenile, we reach puberty. It's a very short duration. Basically, puberty refers to few weeks time, approximately, at the end of the juvenile stage, where you start seeing the specific changes in secondary sexual characteristics. Puberty is where we attain, it becomes obvious in terms of certain secondary sexual characteristics. Or hormonal changes happen in us. So that is a sign that we reached puberty, which happens to be at the end of juvenile period. For about 10 years for the girls and for about 12 years for boys, approximately. It's an average picture which may change again from region to region, population to population. Slight variations can be found. So following puberty, it is adolescence. Adolescence. So adolescence is basically between puberty and the adulthood. Between puberty and the adulthood. So for about 5 to 10 years of period that we spend, where growth spurts happen, we grow in height, weight, secondary sexual characteristics become more prominent after this because they begin in the puberty time, they become more prominent in this time. So basically the time period that we talk in between, the 12 years period to about 18 years period, that is considered to be the adolescence. Okay, after 12 and before adulthood. So adulthood starts about 18 years of age. 18 to 20, slightly different between girls and boys. But approximately 18 years, if you consider that is sufficient here. Adulthood begins from about 18 years or 20 years and onwards. 18 to 20. And old age begins usually because if you see about 50, 55 years or 50 to 60 years, elderly age is after 55 or so. Depends slightly on gender as well. In women, we talk about this time when menopause happens. So when fertility or fecundity is stopped and menopause happen in them, so childbirth, ability to have child, when it is stopped, we can consider that to be an elderly age. So above 50, that usually happens. We'll see the statistics further in the next unit. So about 45 years to 55 years age when this happens. So above 55 years, they can be considered as elderly. Okay, again, there are subdivisions in them, but for our understanding, that is enough. Old age or elderly. Okay, then elderly or old age we get into, and senescence happens here from end of the childbearing years to the death is what is called as elderly age or old age. From the end of childbearing years to the death. So progressive decline is seen here. Progressive decline is seen here. Already aging begins much earlier than this. Aging begins already in the adulthood. After puberty, after adolescence, you start seeing the aging process. But of course, it becomes more and more apparent in the elderly stages. And we lose the ability to perform many other trivial tasks otherwise, and then leading to finally death. So these are the various stages of human growth. Okay, right. So let's get into the details. Let's first begin discussing about the prenatal development. So let's look into the brief idea of what is prenatal development. Let's learn about the concepts of fertilization and these semesters, trimesters. Okay, not semesters, trimesters, 3 trimesters, and how different developments, what are the key developments that happen in them. Okay, right. So first of all, I think even for the fertility part, we're going to briefly discuss this. So you all probably aware that the whole concept of childbirth process begins with the fusion of egg and sperm, right? So this process begins with the fertilization event. So the process here begins with the fertilization event. And what does fertilization mean? Fertilization refers to the fusion of egg and sperm, or fertilization of the egg by sperm. Right, we talked about briefly this concept in the gametes meiosis. So what happens? We have a haploid cell and a haploid cell, haploid gamete, haploid sperm, and a fusion of them. So basically the nucleus of the sperm enters into the egg cell, resulting in a new cell carrying the genetic instructions from two different cells, two different parents. So this process is called fertilization. And biologically, this fertilization takes place in what part of the human body? Happens in females, right? That is called fallopian tube. Okay, briefly, I'll explain this in the fertility process that we need to learn a brief concept about that. There, I'm going to briefly show you this concept, but for now, remember that there is a tube connected to the ovaries, female ovaries, tube called fallopian tube. Fallopian tube where this fertilization takes place. Then what happens to that fused one results in what is called zygote. So fertilization results in what is called zygote. And this zygote, does it develop in the fallopian tube? Where does the zygote develop? Does it develop in the
Uterus,
fallopian tube? Yes,
uterus, sir.
exactly. So what happens from the fallopian tube? It basically installed or implanted into uterus. This is where the development happens. And normally, if that doesn't move from the fallopian tube, it won't survive. Some people actually have what is called ectopic pregnancies, is where within the fallopian tube, you start seeing the further development taking place. That is, it doesn't survive. So it has to move. It has to be a very orderly event, as you see. It has to be a tightly regulated event. Sometimes mistakes do happen. Otherwise, this zygote has to slowly move to the uterus and gets implanted in the uterus. In the process, it's starting to multiply, starting to divide. Let's look into those stages. I'm going to show you here embryonic stages of that happen in the first trimester, and we'll talk about the key events in the second and third trimesters. Okay, some of them I think it's easy for us to visualize. So I have a 5-minute video on this, that either depending on the time I might give you to have a look at it. Okay, but the concept I'm going to explain you here. The key stages I'm going to explain. So this is what we see in the prenatal stage. This is also part of gestation. Gestation, the period where we spend time in mother's womb. Gestation period. Okay, gestation period is where spend time in the mother's womb. So prenatal, before birth, the stages before birth. Okay, so different things happen here. Either we can see in the trimesters, first trimester, second trimester, third trimesters. So 9 months are divided into equally 3 months, 3 months each. Correct? So 3 trimesters. The very first few stages, as I was telling you, zygote gets formed here and moves further. So this is called germinal stages. First few weeks, first about 2 weeks, these things happen. So conception happens here, pregnancy begin here, and implantation. Implantation is when it reaches the uterus and gets attached to the wall of the uterus. So this is called germinal stage. Following which immediately after this is a embryonic stage. So first about 2 weeks is where we start seeing the initial divisions. Okay, and then embryonic stages. Embryo starting to develop. This is first few weeks. So basically we're talking about this is third week, right? So first month to almost end of second month. So about 5-week period, approximately 5 to 6 week period. So by the end of 2 months, embryo is ready. Then we start noticing what is called fetal stages, fetus. Okay, let me give you a brief idea on this. What happens in these stages, embryonic stages and germinal stages and fetal stages. Let's have a brief look at that. As I was telling you, germinal stage is the first stage of the prenatal development. So where it goes from the conception to the implantation, goes from the conception to the implantation, right? That is called germinal stage. And in this stage where we start noticing that cells, this zygote starting to divide, it starts to divide, going through multiple stages. I'm sure in high school you might have briefly read about some of these stages. Okay, we don't have to by heart or to know all the details about it, but few aspects of it is important. Okay, zygote. So what happens? Zygote is a single cell. Zygote is one cell. Fusion of 2 haploids resulting in 1 diploid cell. Resulting in 1 diploid cell. So zygote is a diploid cell, but a single cell. Zygote starting to divide, starting to multiply, adding more and more cells. It goes through various stages. Stages you might have heard about as morula. So it will become 2 cells will become 1 cell will become 2, 4, 8, 16. Like that, there are specific names to those stages. Like 16 cell stage is called morula. Okay, like that, cell starting to divide, adding more and more cells to that component. So this is the process between zygote and embryo. Morula, and morula eventually becomes what is called blastula. Blastula. So morula, blastula, and gastrula. These are the names. Remember a few of them. I'll tell you what happens, and I'm going to show you a video on this. Video on this. Okay, so basically what is happening here, this zygote which carries only single cell, tries to add more cells. In the process, gradual increase in cell number you notice. It becomes morula, blastula, and then gastrula. Okay, and interestingly, it's not just about adding cells. Especially when we move from blastula to what is called gastrula, you notice that there is a specific type of organization that takes place here. The way you arrange the cells plays a very, very important role here. So what do you notice here? The cells actually trying to organize into 3 different layers. Although they showed multiple layers here, I think I want you to focus on only 3 layers. Okay, 3 layers I'll show you that. It is called ectoderm, endoderm, and mesoderm. 3 layers. So usually it looks like this. As you notice here, this is how these stages look like. The real image of that, the scanned image, it goes through the stages like this. Nothing but what this is simplified version of the same thing. So we go through multiple stages. Eventually you notice that cells starting to organize differently. They're going to form layers of it. Okay, mainly 3 layers that we notice here. What are those 3 layers? Endoderm, meso, and ectoderm. Endoderm, mesoderm, ectoderm. The video nicely shows that how these 3 layers stress to different parts of our body. Before that, do you notice any parts of our body, any specific organs of our body? We don't. Here we are only adding cells. But cells eventually give rise to the organization into various structures. This is where formation of various organs begin, by defining different layers of the embryo. So here, what do you notice here? Endo means inside, endo, internal layer. Meso means the middle layer. Ecto means the external layer or outer layer. So 3 layers: internal, middle, external. Biological terms for them: endo, meso, ecto. So endo means internal, meso means middle, ecto means external. So write down these components, okay? Briefly write down these 3 layers and what parts, examples of what parts form from what. The internal layer, imagine what part is actually most internal of your body. Like your digestive system, your stomach. If you cut them, or a cross section, if you do layers of them, you see at the lowest part or internal part of it, you see as stomach or digestive system. Our lungs also come as part of it. Digestive system, lungs, or thyroid tissues, for example. So these formed out of the internal layer called endoderm layer. So each layer results in different parts of our body. So what are the examples for internal parts of the body? Digestive system, lungs, and cells like thyroid cells. Okay. Endoderm results in formation of the most internal parts of our body like digestive system, like stomach, lungs, etc. Whereas the next one, mesoderm, the middle layer, gives rise to the parts that you have in the middle after stomach. If you actually see the next layer of the body, what do you notice? You see blood here, blood, RBC. So from the mesoderm or the middle layer, RBC gets formed, your muscles gets formed. So blood, muscles, etc. forms from the middle layer. Okay. Blood cells, muscle cells are examples for the middle layer, those that form from the middle layer. Okay, see like that actually results in these layers: outer, middle, okay, and internal. So from each of these layers, you will see different parts are being formed. Finally, ectoderm, external layer, outer part of the body. What is the most outer part? Is our skin. Our skin, even nerves come under this, because underneath the skin we have nerves. So skin, nerves, these type of components come under the parts that form out of ectoderm. I know this image is not pretty clear. I'm not sure how well you are able to see it, but this simply explains it. So that's why I'm actually using this image, although resolution is not great for this, but a nice and simplified image.
The 3 layers of zygote are what we are talking about.
From zygote to embryo, we don't call it zygote anymore. We call it an embryo. As part of the development of embryo, we see 3 layers. Each layer gives rise to different parts of our body. So if you have to explain them in detail, you have to write briefly about these stages and what happens. What are the key events? The key events here is organization of the different cells into layers, each layer resulting in the different parts of the body. Okay, right. So like that, we'd start noticing that the various parts starting to form in the embryonic stages of all life. Okay. So few points on this that for you to know is specifically in the embryonic stages. We've talked about that there are different layers, but is there any specific pattern or order of what forms first? Okay, we're talking about the first 2 months of phase of our initial phase of prenatal development we're talking about here. So where we start seeing some rules or principles that our body follows. What happens here? We start noticing that the development goes from the head to tail. First, the part of the head forms, and then towards the periphery or towards the end of the body happens. So starting development begins with the head region. So one principle here is it is called cephalocaudal trend, or you don't have to use this term. The growth happens from head to tail. First parts of the head begin, and then eventually it goes towards the other parts of the body, towards the tip of the body. Head to tail. You will see this in the video. Parts form from the head to tail, or also have a image on this. Then from near to far, like from the center part to the farther part, from the center to the end or periphery. First head, and then what do you notice from the center part, then the extremes, peripheries. So this growth goes from head to tail and from near to far. So why does that happen? Because first when brain forms and various organs related to the central nervous system form, they allow the further development. They regulate the further development of the body parts. So that is why I think we form our head and the brain region and the spine region. Then we move on forming the other parts of the body. So these are some key observations that we make. Okay. So few key principles to make a note of in the embryonic stages, which happen in the first 2 months period approximately, or 8 weeks, 8 weeks. So we notice cephalocaudal trend and the proximo-distal trend. Cephalon, head to tail, and proximo-distal. Proximity means near, distal means far, from near to far. Like that, growth of head takes the precedence. Organ systems near spine grow first, and then extremities. Okay, this is one principle that we notice. Keep this in mind and observe the growth during embryonic stage. This is one stage where we discuss in detail, but majority of the other stages, I think after childhood, it's more simpler for us. The first 2 stages are bit we have more details. Bit of explanation is required for this. Okay, so a very generic picture that you notice here, how our body grows. So embryo to first 8 weeks, and then we call it fetal stage. Okay, our second trimester begins after about a month after embryonic stages. And what do you notice here? You start seeing that the overall parts of the body starting to happen. Don't see too much of a difference here, but I think one image I probably have here, I think would explain that difference. Look at this image, if you're able to see it well. This is Carnegie stages of human development, their classification of what is what. So for scanning and other activities, for other measures, they would use this as a reference point. Okay, so you see the size of them as well. First day, second day, third day, we look like as a dot, small dot. Okay, but eventually after the first 2 weeks, and even in the end of the second week, you notice that few parts of the body begin to happen. So this they consider as an evidence for evolution. We don't look like humans. In the initial embryonic stages, do we look like humans? We don't. We look like more like fish, for example. right? So the initial stages remind us our evolutionary pattern, they say. But eventually, as you notice that various body parts are forming, head is developing. The first part you notice that slowly head is developing, and then spinal part is developing, then other internal organs are developing. So we're talking about here. So month time, by month we come here, and for second month we look like this. Okay, and approximately, yeah, so first month, so second month looks like this, and then further on we look like a baby. This is at the end of the second month. So arms, you notice the legs are forming here. So we don't actually look here already like a human. We look like a tiny animal. Correct? So this is what you notice. Yeah. So first trimester, that as I was telling you, embryonic stages, embryonic growth happen here. The first components take place here. From second trimester onwards, you start seeing the movements, capable of movements in the body. Physical movements can be seen. Body starting to grow. New parts starting to form here. They don't attain the functionality, but they form. Growth happens. Maturity would start a little later, but movements happen. In the arms, you start seeing the movements. Growth in the body, that we have noticed that growth happens in the body here. Clearly, this increase in the size can be seen here. And also reflexes. Baby starting to suck and swallow. So these reflexes start in the second month, beginning the fourth month. Okay, so the third trimester, what do we notice? We start noticing that every part of the body is formed. Every part of the body is there. Baby starts to perform all key tasks, sleeping, wakening, movements, you can call it exercise or movements, turning head and opening and closing the mouth. You can see this when the scanning is done. Normally scanning is done in the fifth month. So that is done at the end of the second trimester usually. That is where you can actually notice that babies, fingers are moving because they take multiple pictures. You can see that fingers are moving, feet is moving, and they're opening the mouth and closing it. So those they can be seen. So mostly evident in the third trimester, but they already happen at the end of the second trimester. But in the fifth month, scanning is a very common thing to see if all body parts are normally formed or not in the baby. So fifth month scan is normal routine in ensuring that. I think prenatal screening that we were talking about, right? So the prenatal screening, fifth month scan is very, very important because they can see various body parts being formed, especially spinal cord will be highly visible, head size will be visible. They can, given the tools now, they can even measure the lengths of them. And already in the third trimester, baby can see here starting to, have respiratory system kicking in. So lungs develop. Okay. So you start noticing that all organs are formed here. They're able to slowly function with the functioning. So third trimester is a very, very key stage. That is why when children are born prematurely, what happens? Instead of ninth month, if they're born in eighth month, seventh month, so they may not perform very well. They have to be put into the incubators because the maturity has not attained it in their body part. So when they're exposed to the real environment, they may not be able to survive. But nowadays, because of the technological advancements, they're able to even, grow them, even save them, even after seventh month. Otherwise, it seems to be very critical. Okay, right. So this is briefly about the prenatal stages before birth. Prenatal stages. Okay, so
second trimester is from.
basically, first trimester is the embryonic up to embryonic stages. The first 3 months. Fourth, fifth, sixth is second. Seventh, eighth, ninth is third. So first trimester is embryonic stages that we talked about. Second trimester is formation of organs. Okay, and few movements. Third trimester is presence of all these organs and slowly functionality gets attained in third trimester.
But there is an acceleration in the third semester, trimester.
What is it?
Acceleration in the development in the third trimester.
Yes, acceleration in the developmental stages, development aspects. So basically, they try to attain the maturity, which will continue even further, right? But the basic elements of this functioning aspects of the body parts would begin in the third trimester. So it is basically its continuation. For our sake, we actually divide them into different stages, but it's a continuous process, right? For doctors and for people, radiologists. So this is a way to identify the stage, to see whether the development is happening as expected, the growth is happening as expected. Okay, right. So watch this video, just 5-minute video. I'm going to share the link. You can watch it at home.
Are we watching it now, sir?
No, you can watch it at home. Okay. So I don't know how well this will play here. So 5-minute video, I'm going to just post the link to it. We're going to end the session here. So I'll post the video link. So you watch it. Basically, what I discussed so far can be seen reviewed here. Okay, so simple. There is actually big videos. You can see 1.5 to 2 hours videos by National Geography on this. But I was looking for something that is more quick and something that visualizes, put the visual before you. So this video I found fits into this criteria. Okay, can I put in the chat box here or in the Telegram channel? I think I'll put in the Telegram channel box. Okay, so watch there. Not a photo. Get to. Yes. Okay. Right. So with that, we stop class here. So in next class, in tomorrow's class, we are going to continue with the remaining stages. I'm going to briefly walk you through the remaining stages of our life. Okay. And then eventually we'll move on to the other topics. Factors. Move on to the factors and methods to study human growth. Okay. So you will see a bit of factual data in this unit. Okay. Some specific information that you have to remember. Okay. Right. Any questions? Okay, good. So for the first part, most of the part that we discussed so far, I think with the running notes, the discussion that you have made from this is sufficient. But with the specific parts of each and every topic, I'm going to give you a bit of reading. I'll see if I can find some reading for this, but it was a little bit more general. So instead, I think if you focus on defining growth development with examples, I'll see if I can put those table into the handout and hand it and give you as well. Otherwise, most of the running notes would be sufficient for this. But on some specific topics that we're going to discuss next, I'm going to give you more reading. Okay, but wherever you feel short of information, if you let me know, I'll give you something more on it. Okay, right, guys. Have a good night, everyone. Then.
Thank you, sir.